Hello guys, my name is Balkrishna Srivastava and welcome to Code with PK. So in this video, we write a C++ program to check if an integer n is a fascinating number or not. So before we begin, it is a request to please subscribe to my channel because more than 95% of my audience is not subscribed and a subscription is very important. So please do subscribe to my channel. So let's begin. So we have to write a C++ program to check if an integer n is a fascinating number or not. Looking at the first example, we have n equal to 192, output is yes. Okay. How is 192 a fascinating number? I'll tell that you in a minute. Okay. Example 2 is n equal to 10, output is no. Right. So what is a fascinating number? The link for that will be in the description of this video. You can read that out. I will also explain here in this video what is a fascinating number. Okay. So, right, if I take an integer n equal to say 192. Okay. How do I check if it is a fascinating number? I calculate 2n, 3n. Okay. Multiply n by 2, multiply n by 3. So this is going to be 192 into 2 and this is going to be 192 into 3. Okay, 192 into 2 will give me 384 and 192 into 3 will give me 576. Okay, so for given n we calculate 2n and 3n and then we concatenate all these three numbers together. So we concatenate n, 2n and 3n, that is we write them together one after the other, 384. Okay, n, 2n and 3n. Okay, so if concatenation of n, 2n and 3n together give you all digits from 1 to 9 exactly once, digits 1 to 9, okay, exactly once, okay, then this is a fascinating number. Okay, so for my digits 1 2 3 4 5 6 7 8 9, 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is there, 8 is there, and yeah, 9 is there. Okay, so 192 is a fascinating number and this is what we code in a program. Okay, there is one minor check that you have to do before checking for this method is fascinating numbers have to be numbers with digits greater than equal to 3. Okay, so must be at least 3 digits. Okay, so if the number of digits in n is less than 3, it does not qualify for a fascinating number. Okay, so this is going to be our first check A and this is going to be a second check B where we calculate n, 2n and 3n, concatenate them together and look for all digits 1 to 9 exactly once. Right, zeros are redundant. That is, the number of zeros do not matter. They can be no zeros, they can be 1 0, they can be any number of zeros. They do not contribute to decide if n is a fascinating number. So going back to the code, right, I am going to write a function bool is fascinating number. Okay, takes an integer n. Okay, this will return true if n is a fascinating number. This will return false if n is not a fascinating number. Okay, so the first check was make sure n has at least 3 digits. Okay, so for this I'm going to write a separate function int get num digits, takes an integer n and returns the number of digits in this integer n. Okay, I've already uploaded a separate video where I explain this code to find a number of digits in an integer in detail. I'm going to copy the code from that. The link for that video will be in the description of this video. Okay, so to find the number of digits in n is straightforward. We convert n to a string and then we return the length of the string. Okay, so I say string n str is toString. Okay, and pass n, right, then I return n str dot length. Okay, so if get num digits within this n is less than 3, I return false. Okay, B part is now making sure we do this entire check of n, 2n and 3. Check if n, 2n, 3n concatenated together have digits 1 to 9 exactly once. Okay, so we'll have to calculate 2n and 3n, right? Okay, so I say int 2n. I cannot say 2n because an identifier name cannot start with a digit. Okay, so I have to say n2, which is basically 2 into n. Similarly, we find n3, which is 3 into n. Okay, now we have to put all these numbers n2 and 3n together. So I say concatenate n, 2n, 3n together. Okay, So I take a string, okay, I name this concatenated is equal to 2 string of n plus 2 string of 2n plus 2 string of 3n. So basically converting n to string, 2n to string and 3 into string, and then putting them all together into one single string. Okay, and now my job is to make sure this concatenated string contains digits 1 to 9 exactly once. Okay, check if the string concatenated contains digits 1 to 9 exactly once. Okay, all right, now how do I do this? So I go back to my processing, right? I have to make sure that digits 1 to 9 appear exactly once. Okay, so I take a boolean array of 10 locations. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, so index 0 1 2 3 4 5 6 7 8 and 9. I set all the locations in this array to false. So false 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 false. Okay, all right, all indices are set to false. Okay, index 0 does not matter to us because zeros are redundant. Okay, now idea behind taking this boolean array is I want this index I, okay, to be set to true if digit equal to I, okay, is found in the string. Okay, all right, so if this digit is found, I set this digit to this location, this index to true. Okay, if this digit 7 is found, I set this location corresponding index to true. Okay, so by the time I am done checking for all my digits in the string, I should have a boolean array where I don't care about what is in the location 0, all other locations from indices 1 to 9 should have value true. Okay, index 1 2 3 4 5 6 7 8 9. Okay, 0 does not matter to us, whatever there is false or true does not matter to us. So if I get this array, okay, at the end of my processing, I know I have digits 1 to 9 in the string, okay, which I want. Okay, but this is not really checking if all digits are exactly ones, which we will take care of in the code. I'll show you how. Okay, going back to the code. All right, so I start with the boolean array contains with 10 locations. Okay, index 0 is redundant. Okay, 0 1 2 3 4 5 6 7 8 9. Okay, 10 locations, indices 0 to 9. We have to bother about indices 1 to 9 because for digit I, index I should be true after we are done processing. Okay, so I iterate this string. Okay, to pick up each character in this string, I say I less than concatenated dot length I plus plus. Okay, I pick up the ith character as concatenated of I. Now this character is going to be some digit between 0 to 9 that I'm sure about because I am getting this character from this concatenated string which is made up of 3 numbers. Okay, 3 set of integers, concatenating 3 integers. Okay, I get the corresponding digit as ch minus 0. The standard way to extract an integer out of a character, okay, that contains a digit. Okay, so if this was single character 2, I get the corresponding integer value 2. How? So we know character constants in Java are associated with ASCII values. So ASCII value of 0 is 48, and so the ASCII value of 1 which comes after 0 is 49, ASCII value of 2 which comes after 1 is 50, and so on till digit 9. Okay, so if you want to extract say 2 out of this single character 2, okay, you basically subtract ASCII value of 2 minus 0. So basically what happens, 50 minus 40, you get 2. Okay, to extract 1 from this character, we do 1 minus 0, character 1 minus character 0. So basically happens 49 minus 40, we get 1. Okay, so this loop will pick up each digit in this concatenated string. Okay, and now we need to make sure all digits 1 to 9 appear exactly once. Right, so if this digit is 0, if digit is 0, okay, digit 0 does not matter to us, so we simply continue with the next iteration. Okay, then for any given digit between 1 to 9, the two possible cases with this contains array is location, the index I either has the value true or has the value false. Okay, now if this digit index is false, okay, if I say bool contains of digit is false, it means I am finding this digit for the first time in this string because the digit index in this contains is still false. Okay, since I'm finding it for the first time, I'm gonna set it true. to indicate I found this digit in the string concatenated. Okay, else. Now else is the case where contains digit is true. Now this is the case where I find digit for a second time. Okay, because in some previous iteration contains digit was false and was set to true, and now again I'm finding the same digit where contains digit is true. Okay, I don't want any digit between 1 to 9 to appear more than once. We want every digit exactly once. Since I get this digit for the second time, I return false to indicate no, this is not a fascinating number. Okay, all right. Now this loop is checking that all digits in this string concatenated appear only once, but it is not making sure that digits 1 to 9 are all there in this string. Okay, so how do I check if all digits 1 to 9 were there in the string? I have to make sure indices 1 to 9 are set to true. This contains array. Okay, so I iterate from digits 1 to 9, and if any of these digits 1 to 9, okay, has corresponding index set to false, it means I did not find this digit in the string, so I return false, that this is not a fascinating number. I have to have all digits being found. Okay, finally I return true. Okay, because this loop made sure that all digits in this string appear only once, and this loop made sure that all digits 1 to 9 appear. So in combination, both the loops making sure that all digits 1 to 9 appear only once and are in the string. Okay, so this is my function that returns true if integer n is a fascinating number, otherwise it returns false. Okay, so let me take an example. In the main, I'll say int n is 192. I'll say cout is n a fascinating number. Okay, I will use a ternary operator for yes or no. Okay, I'll say is fascinating number, call this method. Okay, the first output is going to be yes if the return value for this method is true, second output is no. Right, compiling this, running this, 92 is a fascinating number, yes. Okay, so let's check for more values. Okay, so I am going to iterate from int I equal to 100 because 100 is the smallest 3-digit number. Okay, there's no point iterating from 1 to 99 because they will not pass this check. Okay, right, so I is less than, say let's go to till equal to 10, 1000 and I plus plus. Okay, so if this ith value is a fascinating number, I say cout I is a fascinating number and change line. Okay, so I get to print all the fascinating numbers between 100 to 1000. Okay, going back, compiling, running. 192 is a fascinating number, 219, 273 and 327. Let's check 273. Okay, so we have n equal to 273. 2n is going to be 3 to the 6, 7 to the 14, 1 carry, 2 to the 4, 5. 3n is going to be 273 into 3. 3 is 9 and 7 is 21, 2 carry, 3 is 6, 8. 819. Putting them all together, n, 2n, 3n. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 273 is a fascinating number. Next one is 327. Okay, so you can say n is 327. 2n is going to be 654. 3n is going to be 27, 3 is 81, 981. Okay, so putting them all together, 327, 654, 981. Okay, this is 981. Okay, so 1, 2, 3, 4, 5, 6, 7, 9. So we have our fascinating numbers between 100 to 1000. Okay, let me just change the limit. Okay, make it 10,000. Let's see if we can have more fascinating numbers. We do have more fascinating numbers. Okay, all right, so this was the code in C++ to check if an integer n is a fascinating number or not. I hope you liked this video. This was helpful. So if there are any doubts in this video, or if there is a part you do not understand, please let me know in the comments. I always answer all your comments, and you can always let me know in the comments if there's a question you want to solve, or if there's a concept you want to discuss. All right, so please let me know your thoughts about this video in the comments. Please like this video, please subscribe to my channel, and thank you for watching.